Hi, here is a nice proof of n derivative of product. We are going to derivate this product of this. We are going to derivate this product of this function m times. Okay, we already proved this one. If you wanna see how to prove this one, just go to the previous video where we can see all the details. Okay, now we are taking the concrete example to derivate this function m times. Okay, there is a condition, so n is inferior or equal to the m is inferior or equal to 2n. Okay, let's set f of x equal to x to the n and g of x equal to 1 minus x to the n. Okay, so because we have two functions here as we have here, okay, so we are going to apply the same theorem. Okay, now this derivative function of this m order of this function f of x equal to this sum as k goes from 0 to m choose k, f of the derivative function of this m of order k, which is d order k over dx order k of this function x to the n is multiplied by this derivative function of d over dx, the order of m minus k, okay, m minus k of this function, which is 1 minus x to the n. Okay, so I'm going to derivate this function separately. So this one, so I will have this derivative function of order m equal to, now I'm applying my derivative function. So if you take a look at here, this I will have the same sum as k goes from 0 to n choose k. If you derivative this function is given as n multiplied by n minus 1 and all the way down to the n minus k minus 1. Okay, x to the n minus k. Okay, I'm moving on to the next one. Next one I will have n is multiplied by n minus 1 and all the way down to the n minus this order minus k minus 1. Okay, minus 1 to the n, okay, is multiplied by 1 minus x to the n minus k is multiplied by this original function, which is 1 minus x, okay, to this order n minus this order m minus k. You might say how possible this one can be. I'm going to explain this one a little bit. So in order to find this one, let's take the base case. For example, f of x equal to x to the n, the same function. If I'm taking the first derivative function of this one, I will have f prime, which is f of 1, f prime, the first derivative function, equal to n times is multiplied by x to the n minus 1. If I'm going to apply this one as a k order, so I will take, if I take k equal to 1, okay, as I have here, so this term, it will be n minus 1, which is 0. I will have n minus 0 is multiplied by x to the n minus 1, as you have here. So this term looks like the same because I'm taking k equal to 1. So as a first derivative function, if you moving on to the second derivative function, you will have n minus 1 here, n minus 2 here. Okay, so always we'll have k here. Whatever k is, this one is going in order. Okay, the same thing here for this function with the function g of x equal to 1 minus x to the n. If you try to derivate this one in n minus k order, okay, this one is the same explication, because when you derive this order, always this order n minus m minus k minus 1, as we have before. For this derivative function g of x equal to 1 minus x to the n, when you try to derivate the function, this function n is multiplied by 1 minus x, okay, to the n minus 1. But don't forget there is a minus here. But when we trying to derivate this one n times, you keep multiplying this one by minus 1 by minus 1 into, you have to put the minus 1 to the n. If this one is even, it's giving you plus. If it's odd, it's giving you minus, okay? Then is multiplied by the original function, which is 1 minus x to the n. But here we have the m minus k order. We always to put this order n minus m minus k, okay, is multiplied by this one. So now I'm going to simplify this one now. So on the other hand, this one equal to this written equal to the n choose k is multiplied by k factorial. You can prove this one. Is easy to prove it. Just distribute this one, you can get this one exact, okay? So this one, the same thing here. This one is written on this form, and choose m minus k is multiplied by m minus k factorial, okay? And multiplying by this one. So now I'm going to simplify this one more. So I will have f of x as a m or derivative function equal to this sum as k goes from 0 to m minus 1 to the n, okay, as we have here, is multiplied by m choose k, and is multiplied by n choose k, and multiplied by of n choose m minus k, and is multiplied by k factorial, and is multiplied by m minus k factorial, okay, and is multiplied by these two functions, which is, and multiplied with this function x to the n minus k is multiplied by this 1 minus x to the n minus k is multiplied by this function 1 minus x to the n minus m plus k, okay? So this one, if you take a look at here, this one is the n minus m plus k minus 1, okay? Now I'm going to simplify this one. If you take a look at these two functions, I can put these two functions into one function, okay? By simplifying this one more, f of x as an m order derivative function of this one is giving us this sum as k goes from 0 to m minus 1 to the n is multiplied by m choose k is multiplied by n choose k is multiplied by m choose m minus k is multiplied by k factorial multiplied by m minus k factorial, okay, is multiplied by x to the n minus k, okay, is multiplied by this function. I can put it together, 1 minus x, n plus n is giving us 2n, minus k with this k, so the k will be cancelled out because we have k minus k, minus m, okay? Now I have derivated this function of m order, okay, or m times this condition, this m times with this condition, n is inferior or equal to the m, as m is inferior or equal to the n. So m is taking n as a minimum value and 2n is a maximum value, okay? Now I have done with this problem. Just consider subscribe if you want to get more math. Thank you for watching. I will see you in next video. Bye.